Okay, so from chapter 1 review, we said here, which number in each pair is larger? We said the first one here, 6.3 10 to the negative 2 is the larger one because it is, it means you divide 6.3 2 times by 2 versus 8.6 divided 6 times by 10, that's going to make a smaller number. And then for answer for question B, which one of these two are is the larger number, the 2.5 times 10 to the 8 or the 7 times 10 to the 4th? So tell me first or second, first number or second number? Yes, the second number is, well, wait. The larger one, actually no, it's not the second digit, the second number, because it's 7 of 4 times multiplied by 10 4 times. And here it's 2.5 multiplied by 10 8 times. So actually the first number is the larger one because it's reversed when it's positive and negative. It's yeah, opposite. It's okay. So 2.5 times 10 to the 8 is the larger one because when the exponents are positive, then the larger exponent makes a larger number. But what I want you to be aware is that when it's negative, that's the reverse. You need a smaller exponent to have a larger number. Okay, so I want to do some conversions now. It's time. So how many ounces are in 1,500 grams of carrots? So this is an easier problem to start here. So hopefully you have papers and pencils and you can write, you know, work this out. So how many ounces are in 1,500 grams of carrots? So what I advise you to do is think about what is the given measurement. Given measurement. And what would you say? There's only one here, so it's easy. Grams of carrots. What do you want? You don't want or need? Are ounces. Ounces is a unit of mass. Be careful, there are fluid ounces and ounces by themselves are for mass, but fluid ounces are for volume. So ounces with the symbol OZ. So that means you will need to find an equivalence or an equality statement that relates grams and ounces. And hopefully if you have been able to print and you have the reference for unit 1, so I guess maybe I can show it. So I will change my share here to show the other one, the reference. Yes, you have it, Alexa. So here, the first page of the reference info for unit 1 shows the metric prefixes, but here ounces are English system and grams are prefix, metric. So you want to go into the table where you will have both metric and US. So we said grams and ounces are mass. So you want to look into the rows where you have mass. So towards the bottom of the table. You want to look, so it's not metric to metric, so it's not the first column. It's not the second column because it's not US to US. It's metric to US. So you want to look at the third column and the rows for mass. ounce. And here you can find there is 28.35 grams equals 1 ounce. So that's what we will use. So let me go back to the review here. So equality that we will use is 28.35. No, it's grams equals 1 ounce. Okay, so then you want to think how you will write this conversion factor from this equality. So for this, you need to always start with your given amount. So you start with 1,500 grams, and it doesn't matter that it's 4 carats. Let me find my, and I will multiply, and we will write the conversion factor as a fraction. Right, the equality now will be changed into a fraction where we need to have on the denominator, we want the unit that is the same that you have in the measurement so that you cancel units, right? Because if grams here are in the numerator and in the denominator, then you will be able to cancel the grams. And so you will place the 1 ounce on top. And so this way, by looking at the given unit, you know what part of the equality will go on the bottom of the conversion factor. The grams cancel. I cannot erase them here. They cancel. And so in the calculator, you do 1,500 divided by 28.35. And I will write the calculator answer. So 52.9100. There's more digits after that. So what is the unit of that? Okay, can you tell me the unit in the chat? Ounces, yes. So ounces. Let's run this properly now. So you saw that we did multiplication and division. The rule is to keep the least number of sig figs. So in 1,500 grams, how many sig figs do we have? Can you answer in the chat? So how many sig figs in 1,500? Yes, right, 2. Because those zeros are not significant. We do not see the decimal point. So the 1 ounce, the 1 is exact. So we got exactly 1 ounce and we found out how many grams it was. But the 28.35 is measured. So you need to look at the sig figs there. So how many sig figs in 28.35? Answer in the chat. Yes. So 4. So the least number of sig figs is 2 from 1,500. So we need to keep 2 sig figs. When you count the number of sig figs, you start from the left. So you will keep the 2, and that's going to be 2 sig figs. So you need to stop there. What comes after the 2 is a 9. So you need to round up. And you only look at that first digit after the one you keep, right? If it's a 9, you need to round up. So the 2 will need to be rounded to a 3. The decimal point is just there. So, and because 3 is a non-zero digit, we don't need to show the decimal point. So that would be the answer for this, right? 53 ounces. Everybody knows how to do this now? Yes. It's hopefully because, you know, it's due the homework and all of that are due tonight. So this is just practice to review. So let's do a more complicated one here. So there are several questions within that problem, 11. So if there are 15 milliliters in 1 tablespoon, how many milligram, sorry, I can't read properly. How many milliliters are contained in 3.5 tablespoons of liquid medication? Okay, so that's a problem on its own here. A. So what is the given here? So when you read this, it says, if there are 15 milliliters in 1 tablespoon, you should see this as an equality, right? It tells you 1 tablespoon equals 15 milliliters. So I want you to write this as an equality. Yes, that says 15 milliliters equals 1 tablespoon. Oh, I read my tablespoon like that. So that's the equality. It's not the given measurement. So then what is the given measurement? Yes, 3.5 tablespoon. That's what is given. You have 3.5 tablespoon of liquid medication and you wonder how many milliliters you have when you have 3.5 tablespoon. So want or need is milliliters, right? How many milliliters? Sorry, capital L. So we have 3.5 tablespoon. We want to find how many milliliters is that, and the equality is 15 milliliters equals 1 tablespoon. So let's insert an equation here for the calculation. So, or start your calculation with the given amount, tablespoon, and then multiply. So remember the given amount is in the numerator, right? It's, even though it looks like in the center here, it's in the numerator. You could have a line drawn below and a 1 in the denominator to show you that it's in the numerator. So we start with 3.5 tablespoon, and we have this equality with tablespoon versus milliliters. So we want to cancel the given unit. So you want to put the 1 tablespoon in the bottom, because this way it will cancel tablespoons, because remember 3.5 is in the numerator. So they will cancel. And then the 15 milliliter goes on top. And then equal. So in the calculator, 3.5 is in the numerator, so you multiply it by 15. That's it. And the calculator answer is that. So the tablespoon canceled, so we're left with milliliters, which is what we wanted. So we need to pay attention to sig figs, right? Because when you're multiplying and dividing, sig figs are what you watch for. So 3.5, how many sig figs in 3.5 tablespoons? So you can answer in the chat. Yes, 2. How many sig figs in 15 milliliter? 2 again, right? And the 1 tablespoon is exact. So when you have a conversion between 2 units, one of them is exact and the other is measured. You know, when it's between English and metric system like that. If it's only a metric system, it's all exact because that's been done by definition. But between English and metric, you know, the one is exact and the measured one, the other one is measured. So anyway, we have two, so the one is exact, and we have two sig figs for both 15 and 3.5, so we need to keep two sig figs. So how do we round 52.5 milliliters to two sig figs? Yes, right? So you keep the 5, you would keep the 2, but what comes after the 2 is a 5, so you need to round up, and so the 2 will become a 3. Right, and that's 2 sig figs. So that's the answer for the first question. That was asking how many milliliters are contained in 3.5 tablespoons of liquid medication. So now let's do B. How many milliliters would a patient receive if he took this dosage 4 times a day for 1 week? So here it's not a conversion that is asked. It's you need to add the each time you take the medication, add that to find out how many in total did you take, right? So how many milliliters would a patient receive if he took this dosage 4 times a day for 1 week? 4 times a day in 1 week. So we will start with 53. So the given here, you can still start with the given here and say that it's 53. You would start with 53 milliliters. And that would be for one time, right? So let's see. Each time. Then let's find equalities we know. So we want to know for 1 week. 1 week. I'm not sure I should write this like that, but so 1 week, how many days in 1 week? 7. And how many times per week? Per day, sorry. So in 1 day, you're supposed to take it 4 times, right? That's not a 1. 1 day, 4 times. So you need to take it 4 times per day for 1 week, for 7 days. And each time you take 53, and we could say, you know, equal each time, 1 time or 1 time. So I'm wondering what is really the one you start with. Anyway, you need to kind of multiply all of this together. Let me think about this for a moment. Try this on your own. Yeah. Okay. Yeah, it's kind of that, but let's write it in the way we write those things. So we start with 53 milliliters, and let's make it per time. So this time I will have a fraction, and here it will say for 1 time. So each time you take that, and so you will multiply that by the fact that you take it 4 times a day, right? So if you take it 4 times a day, the 4 times you want to put it here so that you will cancel the times. So 4 times per day. And then you multiply by the fact that you want to take that 7 days for 1 week. And so 7 days for 1 week, that means you will put days here on top because you want to cancel with days on day on the bottom. So 7 days for 1 week. And then, that's not what I wanted to do. Equal. And so if you do this, you see that the times cancel, the days cancel, and you're left with milliliters per week. And so that's what we wanted. We wanted to know what is the total amount of medication you take in a week. Milliliter per week, right? And so, as you said, it's 53 times 4 times 7, which is 28. That's the calculator answer. So, so how many sig figs should we keep here? 53 had 2 sig figs. 1 time is exact. 4 times is exact. 1 day is exact. 7 days are exact. 1 week are exact, because all of these are exact equalities. So we need to keep 2 sig figs because of the 53 milliliters at the beginning. So we have 1,484 milliliters per week. So we want to keep the 1, the 4. That's 2 sig figs already. So what comes after the 4 is an 8, so you need to round up. So the 4 will become a 5. And be careful, it's not just 15, it's the 1 here is in the thousands place. So how do we make it so that it's in the thousands place? What do we do after that to make it back to 1,000? Yes, you add 2 zeros, right? By adding 2 zeros, you show that the 1 is in the thousands place, the 5 is in the hundreds place. And you do not show the dot because otherwise it would be 4 sig figs, and you want to keep it 2 sig figs. So milliliters per week. So sometimes, yeah, calculations like that have not a single unit. Yeah, I'm sorry about that, because I say your measurements, given measurements should always be the one with the single unit. But sometimes it doesn't work this way. So this way we calculated the amount that would be taken for over a week. How many liters does this correspond to? So back to simpler conversions here. So how many liters? So we know the amount per week in milliliters. So the given here is the milliliters, given 1,500 milliliters per week. You could keep it as milliliters, it's fine. We want or need here liters. And so you want to find the equality between milliliters and liters. So either you know it by heart or you look for your metric prefixes. And here, milli, so equality. There's 2 ways to write it. So either you take 1 milliliter from the prefix table and it says 0.001, and then you bring back the base unit, liter. I like to multiply this by 1,000, I prefer to say, or if you multiply by 1,000 on the left side, it's 1,000 milliliter equals 0.001 multiplied by 1,000 is 1 liter. I prefer to use this form than, it's up to you. Both are equivalent, they mean the same thing. And then insert the calculation that we will do here. So the given is the 1,500 milliliters times. So these from the metric prefixes are really easy to do because when you're used to them, you know that it's just a matter of moving the decimal point. But let's do it this way so we practice. So I will use the 1,000 milliliters equal 1 liter there. I'll place the 1,000 milliliter on the bottom to cancel milliliters and 1 liter, 1 liter on top. Right? Milliliters will cancel this way. We're left with liters. And so 1,500 divided by 1,000, it's 1.5. Is it correct as far as sig figs are concerned? 1.5. So should we keep it like this or not? Yes, it's correct because so 1,500 milliliters has 2 sig figs. The 1 liter is exact. The 1,000 milliliters are exact. I told you earlier. The metric prefixes are all by definition set to those values, so they are exact. It's exactly 1,000 milliliters in 1 liter. So these are not limiting. So 2 sig figs in the given, so you need to keep 2 sig figs in the final answer, and 1.5 is 2 sig figs. Okay, so hopefully you still have time to go through a few more. We can do at least the temperature here. So a cake is baked at 350 degrees Fahrenheit. Convert this temperature to degrees Celsius and Kelvin. So again, hopefully you have the reference for unit 1 here. It shows you the temperature conversions formulas. And so here we start with degrees Fahrenheit. And we want to find degrees Celsius and degrees Kelvin. So to get the Kelvin, it looks like we need the Celsius. So we will start with the Celsius. When you need to find the Celsius, you want to use the equation that says degrees Celsius equal, and then plug in your Fahrenheit in that equation. So you want to use the one that says degrees Celsius, equal, and it says degree Fahrenheit here. Oops, degree Fahrenheit minus 32 over 1.8, so divided by 1.8. Okay, so when you do anything that involves an equation, I want to see the formula, right? When you will do the exams on paper, I want you to show the formulas that you will use. It's important. So let's plug in the values. We have 350 with a dot here, degrees Fahrenheit, minus 32 divided by 1.8 equals, so you do this on your calculator. 335 minus 32 needs to be done before you divide, right? So you need to do enter. It's important here when you do 335 minus 32 that you type enter to your calculator before you divide by 1.8. Because if you do not do that, I will tell you what you will get. So that's the calculator answer when it's correct. But if you do 335 minus 32 divided by 1.8 without using parentheses or entering the intermediate answer, you will get 332.222, right? It's wrong because the calculator does 32 divided by 1.8, and that's what it subtracts to 350 instead of doing the subtraction first. So just be aware of how you use your calculator. So here it's degrees Celsius, and we need to round this properly. With temperatures, you round the temperature to the same precision as the least, well, you round with the same precision as the given temperature. So here 350 is given to the ones place, to the degrees. So you want to give the final answer to the degrees, to the ones place. That means you stop at the dot, right? So you will have 176. You will stop there. But what comes after the 6 is a 6, so you need to round up your 6, and so it will become 7 there, and then degrees Celsius, right? For temperature, it's not, you do not follow the rules for subtraction and division. What you follow is the fact that you want the same precision for the final temperature as you had for the initial temperature. So it was given to the degree, so you give it to the degree. If it was, you know, 350.5, then you would give 1 decimal in the degrees. Okay, so that's what is particular about temperatures, is the rule to round is different. So do you still have time? Oh, is that the equation? Wait, did I do something wrong? Wait. No, it's correct. Sorry, I was not sure anymore, but that's the equation you would use when you have the degrees Fahrenheit and you want the degrees Celsius. You want to use the equation that says degrees Celsius equal as a function of degrees Fahrenheit. The other equation is degrees Fahrenheit equals 1.8 times degrees Celsius. Well, let me show the reference. I forgot to show that. Here, out of these equations, when you have degrees Fahrenheit and you want degrees Celsius, you want to use the second equation there, because you want to plug in the Fahrenheit, subtract 32, divide the whole thing by 1.8. That will give you the degrees Celsius. Okay, yeah. So we still have to do, let me go back here. I forgot, we still have to do the Kelvin. So let's do the Kelvin now. So Kelvin are very similar to degrees Celsius in the sense that their degrees are the same size. It's just offset by 273. You saw in the previous share that Kelvins, there are no degree symbol in front. It's just Kelvin K equals degree Celsius plus 273. That's it. So you take the degree Celsius, degree Celsius plus 273 equal, oops. So here you keep this precision to the degrees, to the ones place. So 177 plus 273 is 450 Kelvin. So again, Kelvins have no degree symbol. They're just capital K. Okay, no questions about that? Okay, let's go through some density problems here. 3 liquids have densities of 1.15 grams per milliliter, 0.79 grams per milliliter, and 0.95 grams per milliliter. When the liquids which do not mix are poured into a graduated cylinder, which liquid will sit at the top and which liquid will sit at the bottom? So let's answer this one. Which liquid will sit at the top? What do you think? Is it going to be A, B, or C? So you can answer in the chat by telling me A, B, or C for the one that sits on the top. Yes. Some more tries. Others? Okay, so yes, it's B. B is the one that will be sitting on top because it's 0.79 grams per milliliters, and that's the lightest density, right? Let me make it be not capital. So, B. Right, so the less dense will sit on top, right? And so then which one will sit at the bottom? So tell me in the chat, which one will sit at the bottom? Yes. Let me just copy that. The more dense will sit at the bottom. That's what density does. You know, the more dense it goes downward. It's more, it's like more heavy. And more, there's more pull from the gravity on it. Okay, so let's do a final problem here. So liposuction is a cosmetic procedure used to remove excess fat from the abdomen, thigh, or buttocks of a patient. Question A, if 2 liters of fat, and we are given the density, is removed, what is the mass in grams of this fat? So let's do question A first. So it's if 2 liters of fat is removed, what is the mass? So you know that density relates grams to, grams to milliliters or mass to volume. Here, density is given in grams per milliliter. So density, because of its unit being complex, is always used as a conversion factor. So here we can tell that density will be used as an equality. That will say 0.94 grams equal 1 milliliter. That's what it means, really, from density. And so that's an equality. So it's not your given. That's not what you will use to start your measurement, your calculation, I mean. So then what is the given? It's going to be the 2 liters of fat, right? 2 liters of fat. So yes, 2 liters of fat. And so what do we want? What do we want to calculate? What do we want or need? So you read the question. If 2 liters of fat is removed, what is the mass in kilograms? So what we want is the mass in kilograms. Mass in kilograms. Yes. So you will start your calculation by doing 2 liters of fat. However, the equality we have here is in grams per milliliters, right? So that's not gonna help us yet. We need to change our liters into milliliters so that we can use the density. So we need more than one equality here. And we need an equality that will change 1 liter into milliliters. And we saw that earlier, it's 1 liter equals 1,000 milliliters. Then we can use the density to change the liters. Sorry. So first you change the liters into milliliters. Then using the density, you change the milliliters into, let me write this in, so from liters, we will, let me insert that as an equation. Liters, yes, liters are D. Okay, liters, let's use an arrow to show that we will change that to milliliters. Once we have milliliters, we can use the density to change the milliliters into grams. And once we have grams, we can change that back to kilograms because the question is asking for kilograms. So that's what we will want to follow, this roadmap here. So to change grams into kilograms, we need another equivalence here, equality. And so if you look at your, let me share that quickly here. If you look at the metric prefixes, kilo here is worth 1,000. So 1 kilogram equals 1,000 grams. So let's write that back in our document here. So 1 kilogram equals 1,000 grams, right? So now we can start writing our calculation. So we start with 2.0 liters. We want first to change that to milliliters. So we will use this equality that says 1 liter equals 1,000 milliliters by canceling liters. So you want to have the liter on the bottom. So it cancels with the liter in the numerator. And 1,000 milliliter will go on the numerator. Remember how 2 liters here is in the numerator. So that will change the liters to milliliters. Next, you want to use the density to change the milliliters into grams. And you want the milliliters on the bottom to cancel the milliliters from the previous step. So it's 1 milliliter on the bottom and density is 0.94 grams per milliliter. Next, you multiply by, so at that point you have changed your liters into milliliters and into grams, and now you want to change the grams into kilograms. So the next conversion factor you will use is 1 kilogram equals 1,000 grams. And you want to have the grams on the bottom and 1 kilogram on top equal. So liters cancel, milliliters cancel, grams cancel, and we are left with kilograms. So we know it's correctly set up. Then in the calculator, you do 2.0 times 1,000, because 2 is in the numerator, you multiply by 1,000, divided by 1 is not necessary, multiply by 0.94, divided by 1 again is not necessary, multiply by 1 and divided by 1,000. So multiplying by 1 is not necessary. You could just simply divide by 1,000. Equal 1.88 is the calculator answer there. So let's pay attention to sig figs. So the conversions coming from the metric system are all exact. It's 1 liter exactly equals 1,000 meters exactly. 1 kilogram is exactly equal to 1,000 grams. So these are not limiting. From the density, the 1 milliliter is, so from the density, the milliliter is exact. The grams are measured. So here we have 0.94, that's 2 sig figs. And 2.0, that's also 2 sig figs. 2.0, 2 sig figs. So we need to keep 2 sig figs at the end. So we will keep the 1.8, that's 2 sig figs. What comes after the 8 is another 8. So you need to round up. So the 8 here will become a 9, and then kilogram. And that's 2 sig figs. Okay, and that ends that problem, and it's 11:30. I think it's time that I stop. Hopefully that was helpful. This is recorded. Let me stop the recording now.